106, scientific notation. A number is written in scientific notation when it is between 1 and 10, and multiplied by a power of 10. So we're going to start out with some pretty easy numbers and kind of work through why scientific notation is the way it is. So 2 million in standard form, I would write out the number. So here's 2 million. I'm going to go back over here and I'm going to show some work for that. So I could write that 2 million is 2 times 1 million. So now I have a number between 1 and 10. 2 is between 1 and 10, and I have times, but I don't have a power of 10 right now. I have 1 million, so I need to figure out what power of 10 that actually is. So for that, I'm going to go up here in the margin, and I'm going to show you a little bit of scratch work to just help our thinking. So we know that 10 to the 0 power is 1. We know 10 to the first is 10. Anything to the first power is itself. Anything to the 0 power is 1. If I want to find 10 squared, I know that's 10 times 10, and 10 times 10 is 100. If I want to know 10 to the third, that's 10 times 10 times 10, which is 1,000. So we come up with this interesting pattern for powers for 10, where if I have a 1, I have 1 0. If I have 10 squared, I have 2 zeros. If I have 10 cubed, I have 3 zeros. So what I can do then, if I want to represent this 1 million as a power of 10, is I can just simply count the zeros. 1, 2, 3, 4, 5, 6. I have 6 zeros, so it must be 2 times 10 to the 6th. So that's what I'm going to write over here for my scientific notation. For 5 thousandths, I'm going to first write that as a fraction over here. 5 over 1,000, that's what that literally means. If I was going to actually write the standard form number, though, I need to remember it's 0. This would be my tenths place, my hundredths place. This is my thousandths place. So this is what it would look like in decimal form. And here it is as a fraction. So I'm kind of doing this scratch work over here on the left, like I did with the first one, to show how we get that answer. So I'm going to write this as 5 times 1 over 1,000. I think I'm going to use the x for times here. So 1 over 1,000, let's think about that. It's in the denominator, so it has to be a negative exponent, and there's 3 zeros. So that's going to be 5 times 10 to the negative third. So now let's look for another pattern. We don't always want to write this. Doing the little work that we did over here on the left was very cumbersome to figure out those answers. So let's see if we can find a shortcut. So right now, in the standard form number for 2 million, my decimal's here. I want the decimal to be over here, right after the 2, because I want to have the number in front of that decimal. I want to have whatever number I'm looking at between 1 and 10. I want to only have one digit before that decimal. So I have just moved the decimal 1, 2, 3, 4, 5, 6 places. So that's where I get that 10 to the 6th power. On the second one, my decimal's over here, but I want to move it past that 5. So I have just a 5 in front of my decimal. So I moved it 3 places in the other direction. It was a small number, so -3. So that's kind of how all this works and how it got started. It makes sense that we use scientific notation when we're dealing with things like space. We're looking at such astronomically large numbers. It makes sense to have a way to notate them and write them with a shorthand instead of just writing 0 after 0 after 0. So scientific notation is really common. We're going to write each of these numbers now using scientific notation. My decimal is over here. I want to move it so I have one digit in front. A number between 1 and 10 is what we're looking for. So we want to move the decimal over to here. And then we need to count how many places. 1, 2, 3, 4, 5, 6 again. So we'll have 3.57 times 10 to the 6th. On the next one, my decimal's right here. I need to move it so I have one digit between, or one digit in front of my decimal. So that would be negative 9.8035. It is a negative number. So ideally, we're looking at that 9.8035. That's between 1 and 10. That's why I kind of like to think of it as just one digit before the decimal, because you can have negatives. And then this will be times 10 to the, we move 2 places, so 10 squared, 10 to the second power. On this one, I want one digit before the decimal again, so I want it to be 3.24. I want my decimal to be over here. So I'm moving it 1, 2, 3, 4 places. So times 10 to the fourth. My last one, it almost is in scientific notation. 2.34, I only have one digit before the decimal. But if I want to write it in scientific notation, I have to have times 10 to a power. So I'm going to add in a 0 because I know 10 to the 0 power is just really a 1. But I've written it in that same notation that the rest of them are in. Now we're going to work backwards. We're going to start with something that's in scientific notation. We're going to write without the power of 10. We're going to write it in standard form. So for number 5, I want to multiply out this times 10 to the 10th power. That means I need to move my decimal 10 places. So I will move it 2 places past the 7 and the 6. But because I need to move it 10 places total, I need to add on 8 zeros. So let's think about that again. I need to move it 10 places. So the decimal's right here after the 8. I move it past the 7 and then the 6. And in order to keep moving it, I have to fill in with zeros. And because I've already done 2 places and I need to do 10 total, I need to add 8 zeros in. So let's go through and just double check our zeros. 1, 2, 3, 4, 5, 6, 7, 8. And then I'm going to add commas to make my number easier to read. And I'm all set. On number 6, it says 10 to the first. So I'm going to move it only 1 place. So now I have 52.5. So sometimes even after you convert it into a standard number, it may still be a decimal. The last one, I have a negative exponent. So all of these numbers we worked with so far are big numbers. And so we have really big powers. When I have a power like -9, when I have a negative exponent, I have a really small number. So I need to move the decimal in the opposite direction. So this time my decimal is going to go this way. And I'm going to have to fill in zeros between my decimal and my 589. So I'm moving it 1 place here, and I want to move it 9 total. So I'm going to have to add in 1, 2, 3, 4, 5, 6, 7, 8 zeros. Normally, I would not make all those little marks. I would just count them. But that was just to give you an idea of what we're looking at. And then I usually write a 0 in front too, just because I think it looks nicer. Order from least to greatest. So we know the numbers that are smaller will have our smaller exponents when we're looking at scientific notation. So 8 is definitely smaller than 9, so it stands to reason that either 6.2 times 10 to the 8th or 7.9 times 10 to the 8th will be our first when we go from least to greatest. So I have to look now, since they both have the same exact exponent, I need to look at just the 6.2 and the 7.9. So first I'll write down 6.2 times 10 to the 8th, and then 7.9 times 10 to the 8th, and then last will be the 1 to the 9th power. Now I'm looking at which is the smallest. So the smallest number should have the smallest exponent. So you might look at this and be tempted to pick 10 squared as our smallest exponent, but that's not true, because -5, a negative number, would actually be smaller than 2. So if you look at it that way, my smallest is going to be -5, the -5th power, and so the smallest number is 9.2 times 10 to the -5th. Compare 9 times 10 to the 5th to 3 times 10 to the 3rd. So this is a multiple choice question on your quiz. And what they're really looking for is how many times bigger is one than the other. So I want to first compare the 9 and the 3, and I would say 9 is 3 times bigger. So I'm going to write down a 3. And then the 10 to the 5th versus the 10 to the 3rd, this is 2 decimal or 2 digits bigger, right? This is 2 tens bigger. So I'm going to write times 10 squared. So now I'm going to work out exactly what this is. This is 3 times 100. This is 300. So 300 times larger. So just to add some notes in here, with the 9 and the 3, we divided. And then when we were looking from the 10 to the 5th to the 10 to the 3rd and trying to figure out how many bigger, we really subtracted those. So we're going to try the same thing on 11 now. 6 versus 3. 6 is 2 times bigger than 3. And now I have to figure out 10 to the 5th versus 10 squared. Well, this would be 3 factors of 10 bigger, so times 10 to the 3rd. And now I'm going to multiply out 10 to the 3rd as 1,000. So that's going to be 2,000. So it's 2,000 times bigger. You should be ready to go ahead and take your quiz now on 106. Good luck.